Hi, ladies and gentlemen, welcome to this special AMS and car design news live stream hour focusing on lightweighting next generation vehicles. Very excited to be with you and to be joined by, as you'll soon learn, a very esteemed panel of experts from across the sector. My name is Christopher Ludwig, editor-in-chief here at Ultima Media and our brands. Of which this is a collaboration, Automotive Manufacturing Solutions and Car Design News, where we're bringing together an audience of a panel of both designers and manufacturing engineers.
As Chris, I'm Nick Cole, editor at AMS. As Chris mentioned, this show is going to give you multiple perspectives across vehicle development, R&D, design, and manufacturing engineering. And as you can see, we'll be joined by expert speakers from Ford, Gestamp, SSAB, and ArcelorMittal. So later on, you'll have the opportunity to hear from and ask questions to the presenters across the value chain. And you can ask questions and post those ready for the Q&A session at the very end of our guest panel's presentations via the chat box in the bottom right-hand corner of your screen.
Absolutely, and you know, Nick, I think one of the reasons that we're doing this session in this way, we're bringing together such a diversity of talent here, is because we really see lightweighting rising up the agenda in the automotive industry and in manufacturing and design. We're talking about issues, of course, electric vehicles, electrification, putting more demands and requirements on lightweighting to deal with range, but of course also the emissions regulations. So obviously lightweighting totally critical for petrol vehicles as well, and that brings with it lots of challenges and opportunities in the manufacturing and design area. We're going to be talking today with some specialists from steel and body exteriors and things, but we're also going to talk about opportunities in the interior and in material selections that are made, alternative and lighter weight parts, and indeed some of the innovations that can come from these materials and these architectures, whether that's the frunk in electric vehicles or how we deal with some of the challenges in the softness of material, but also strengthening it at the same time. And I think one of the really key messages we're going to come back to again and again is this collaboration and change across the R&D manufacturing process, integrating design, engineering, manufacturing, and some design for manufacturing principles that we're going to hear from some of our experts on shortly.
And as you mentioned there, Chris, lightweighting is an ongoing pursuit, but it's now becoming sharp focus because of the EV transition to electric vehicles. And one of the things we want to cover in this live stream is how OEMs and tier suppliers are optimizing their use of these materials and application of them, and in doing so, meeting a lot of engineering challenges. I mean, battery enclosures is one that comes up quite regularly, and what we're seeing is that the design challenges are being met. We're seeing a lot more use of digital tools, sort of fast prototyping and simulation of material properties as well, which is giving the designers and the engineers greater vision around, or greater transparency around, what those materials will do in a certain application. And we'll be hearing more about that from our presenters later on. And you can read some more about these innovations. We recently covered a lot around the sort of, to use a broader term, digitalization of the manufacturing process in our latest digital edition, which covered sort of future factories. There's a link in the chat box for that, so you can click onto that after the presentation and have a read about that.
Yeah, just a couple of words about the flow of our program today. As you saw, we're going to hear from each of our expert guests and teams up front for some one-to-one and some direct insights. We'll hear first from Ford on design for manufacturing innovation for some next generation pickups. We're going to talk about design optimization for low-weight EV concepts with Robert Strum at SSAB. We'll talk about higher crash safety and simpler battery solutions with Gestamp and more. And as well as touch on opportunities in body and light subassembly with ArcelorMittal. And then at the end, so we'll the first half of the show will be kind of hearing from all of the guests, but at the end we're going to come together for a really interactive panel Q&A. So put your questions throughout, and we'll look to address them in the Q&A as much as we can. And if we don't get to it, because obviously we have a lot to get through, we'll make sure that these experts get your questions and have an opportunity to answer them.
We'd like to thank our sponsors, SSAB and ArcelorMittal, for supporting this live stream, and also for providing some experts for our panel. SSAB, you might be aware, have had their Docol EV design project, so we might be hearing some insights from our guest on that. And ArcelorMittal have had their ongoing S in Motion project, which has been developing lightweight body structures for a number of years now, evolving for each iteration and the differing demands as the market changes. So we'll hear more from them later on.
Fantastic. Well, with that, we're gonna shortly bring on our first guests and some key designers from Ford, both on the interior and exterior side. Scott Anderson, who's a lead interior designer for SUVs and trucks, and has very recently worked on some projects such as the Maverick, a compact truck and with a hybrid, as well as the Bronco, and Elvir Meselik, who's a senior exterior designer, and some of his key work is recently on the F-150 Lightning. Of course, this is a really interesting and important vehicle when we think about lightweighting and other aspects of design and engineering. And Elvir also had some real interesting input on things like the Mega Frunk, which I think we'll probably hear a little bit more about. And so Scott and Elvir, we're so glad that you could join us here for this live stream. So if you can join us there, Scott and Elvir, great to have you here.
Good morning. Thank you.
Hi, everyone. Good morning.
Great. I'm going to hand over to you guys now. I think Scott's going to kick us off, and then we'll catch up with you right afterwards.
Yeah, thank you very much, Chris. So quickly, I'm just going to take you through some elements of the Maverick. Important thing to note, this Maverick, it's a new entry in the marketplace, a truly compact truck. So the goal was to meet this new customer's lifestyle, be extremely efficient, extremely cost sensitive, to make sure it was the right value proposition. And some very important key program words were essential, encourage. Essential being simple, not basic, and satisfies. So paring it down to its core essence, being very reductive, and being courageous to try things different and new for our customer. So, we looked at this as the new compact. We wanted to be honest with the surface and design. And that means letting structures, letting functional elements showcase themselves in the design language and celebrating them. And that's a very different take and approach than most interiors. So instead of structures being placed and then making them pretty, we looked at how do we reduce and make the structures beautiful, enabling adventure, enabling things to happen with families, clever use of space, simplicity for maximum understanding, integrated design, also a key part of design for manufacturing. Having some character, right? Really creating something unique and has a big personality, honest surfaces, very human interfaces, hyper comprehensible. So paring it down very simply allows people to understand how to use it easier and quicker, which also reduces part count, assembly time, and creates a more integrated approach. And then how do we create personality? We used a lot of in-mold surface texturing, like product design you see in the world, to create interest and value. Instead of trying to make things look like leather when they're not, we're very honest about the plastics use case and making the plastics have a personality, and using things like bright colors and insert dual shots, for example, in the vent vanes, gave it an intense personality. And also important to our customer was the idea of being sustainable. So showcasing recycled materials and putting them on as a first surface read. So we had this idea of personality up and cost down was a massive part of the program. And then lightweighting and reductivism came out of that idea and approach. So we had a huge workshop, tried to do reductive design, finding what's the most valuable straight line to the customer. And you can see as we designed this, the surfaces and the language of the interior, things like the gray speckled plastics and the navy pure color, and how we made this very functional product design aesthetic shows how we were very reductive in our approach. And that's a very important point. And that's where a lot of the design manufacturing came in. You'll see lots of these little details around the interior, like the orange handle, grab handle pulls. It costs $0 to make that plastic orange versus black. And that $0 benefit to the customer is a little bit of a excitement value, personality, and it tells me where to interface with the interior. So the little orange vent vanes are actually two-shot, dual-shot overmolded to create intense color when needed or wanted. They can go black for the base value and go silver for the lariat or premium value. So the idea is that we're using the material science and manufacturing techniques. You know, for example, the little side panels on the end caps of the instrument panel, this is a one-piece instrument panel. It's pulled from the rear. So we had to make end caps on the side that closed out the holes for the tooling slides. And those extended end caps became a point of pride. We put a Built Ford Tough logo there. You know, things as simple as the D70 cluster surround usually is a separate element that just blacks out the air around the cluster. And the IP topper comes over it. You make a cluster bezel and a decorative trim ring. We said scrap that. Let's make a completely separate piece for the D70 and integrate it right to the topper and poke it through the substrate. So now the functional D70 cluster surround became part of the design language. And it actually was very successful in actually adding value to the surface topology of the topper and the color break. So an example of taking a reductive approach in design for manufacturing, if the part doesn't need to exist, don't make it. So we created a decorative element out of a structural functional element. Speckled faceted plastics. This is not a luxury car. It is not going to be sold in a premium price point. It doesn't need to pretend to be leather and chrome because that's not valuable to this consumer. So we looked at the plastics and said, how can we make them more exciting and enticing? We used high graphic color break in the series and created this really unique recycled material carbon chop and put it into the plastic and faceted it like a stone face texture. We did the same in the door trim panel. So what you have here is an enhanced personality with the speckled and faceted plastics for free, literally. And it's using, you know, manufacturing. We created new surfacing techniques to create these tessellated surfaces and new manufacturing techniques. We took advantage of the die draw of the mat pocket to create this bottle holder. So normally you have a mat pocket below the armrest. We cut the armrest away from the door pull and made an expansive mat pocket that went up into the upper door and became part of the color break on the upper door. So we basically got a decorative element and a functional element for free together. That gave us expanded storage. We did these little things like striped surface texturing. All that was working with our manufacturing partnerships to create reduced gassing in the tools to make the stripes work. You can see the clever little grab bars on the B side. We always rib the back side of mat pockets, but the elements here were tuned to help hold that bottle tightly in place. And you can see the little gray speckled piece that protrudes that sort of holds the bottle and nestles it. And in the back of the mat pocket, again, taking advantage of the die draw of the part and making the mat pocket B side and exposed A side, allow us to put elements in, like when the bottle tilts rearward and falls back, it gives you a place for it to land. So all these little details, right? The cantilevered handle that made room for the bottle needed to have fasteners to structurally support it. So we exposed those fasteners, making it easier to manufacture, but also creating a unique design element out of it, right? Instead of covering those fasteners up with clips and panels, we said, hey, let's celebrate that and make that a FORD branded bolt. And now that's in our catalog to use in other programs. Something as simple as the console had a Z die draw, a single piece console. So we took the functional closeout panels that were needed to put slides in the tool to mount this thing to the structure. We made a decorative element out of it. Instead of just making it a blue cover panel, we changed the color, we put the striped texture on it, and made it almost feel as it's like a tough kick panel, Built Ford Tough. And you can see the different grain breaks and technologies we use in sliding the tool. And this was a huge design element. We had to work close with our manufacturing partnerships to understand mold flow, stop outgassing from the stripes in the tool. And it created a very unique look for the customer while allowing us an access panel. We exposed the fastener again and made that part of the design language. So really reducing the parts down. I think the core program this came from had a 16-part center console. This center console in total is about 7 parts. So a huge amount of reductionism and creating lots of functional use cases at the same time. The Z die draw we took advantage of, do things like the phone holder. And we used the rubber mat pocket insert that we knew would be there to amplify the clasping of the phone and allow it to grip the phone well for the passenger side. And you could see how just using that sort of manufacturing reductionism gave us pretty unique geometry and really functional geometry. The black surround around the shifter was actually the bracket that bolts the shifter to the console. We said, let's cut away the console with a hole and an opening portal and expose that bracket and feature as a design element. And it became the first sort of structurally designed part we exposed on the product. At the same time, the rubber mat, we said, let's make it an orange color. Why make it black? You know, in the middle, you can see a black version. The top left, you see an orange version. That gives a design element to the customer that they know where their storage goes, right? And it gives them a really simple, comprehensible use case, user experience. Fit slots, we started generating ideas about modularity. Again, we used the back of the console as a X die draw pull, and then we had a tool slide that went in the vertical Z direction to create this unique storage solution opportunity where people could upfit with simple accessories or even 3D print their own into this fit slot. And we did that all through really intense focus on manufacturing. We took a part that was already there, that already had to be tooled to close out the back of the center console in the structure of the console. We used the tooling die draw angles and designed around those premises to create this fit slot to create a unique customizable opportunity for the consumer. So with that, I'll pass it to Elvira to talk to you a bit more about the Lightning. Hopefully that gave you a little taste of what the Maverick was all about and how we use design for manufacturing to simplify it. Thanks, El. Thank you, guys.
All right, here we go. I'm gonna give you guys a little insight and into how we developed our first F-150 Lightning, our first electrified pickup truck. And we and the product and development at Ford were very excited about the value proposition a frunk would bring to the pickup truck segment. And with that in mind, we created a dedicated interdisciplinary task team inside of Ford, consisting out of various departments, right? Like I was the lead designer on the frunk and worked heavily on an everyday basis with engineering, with our UX team, with program management, our suppliers, etc. So through our through our advanced work and extensive market research, we got confirmation that our customer was looking for a completely different execution frunk execution in comparison to what we find in a regular passenger vehicle. Our customer values productivity and functionality above everything else. So a small, well-executed little jewelry-like cargo area underneath the hood wouldn't cut it for a customer. So those market research insights were very valuable to us and helped us define our design drivers, which were productivity, durability, and serviceability. So with that now that we had that established, we went to work and try to make the frunk, try to make this the most productive frunk that has ever come to market. So in order to fit 2 golf bags or 3 potentially 3 suitcases, achieve best-in-class cargo volume and load weight capacity, we started off with a shrink-wrapped blueprint of the frunk, which initially led to quite a lot of tension between design on one hand and engineering and the program team. We were picturing a perfectly symmetrical frunk right from the beginning, whereas our counterparts were more keen on higher cargo volume numbers than let's say creating perfect order inside of the visual order inside of the pickup truck. So after I'd say like 2 weeks of passionate discussions, we had to find a middle ground here and sought some alignment, and conclusion was that we walked away with that we in design won't shoot for perfect symmetry, whereas the rest of the team will actually help us execute a somewhat symmetrical layout, which was very important in my mind in order to give the customer just a nice natural order once the hood opens. So once that was out of the way, I realized that it was time to set a vision for the whole team and we needed I thought so, we needed a visual anchor point for all of us, and I set out the vision to treat the frunk more like a durable and versatile cooler box. And now that I look back at that moment, I must say that I think that was a crucial point in our development and during our process. It really helped us build momentum and brought us all together, and we had a common goal from here on. And based off of this slide here, I'm going to show you all, I'm going to tell you a little bit about our development process, how we went about it, and I will point out a few very valuable productive features that can be found throughout the whole frunk. So at first, we build our side walls and the floor. Here we used a compression molded sheet metal compound that is pretty strong and at the same time very light. And it, aside from helping us with our fit and finish, for instance, right here where we have a scuff plate that's that needed to be integrated, the SMC enabled us with tight gaps here. Aside from that, it also helped us achieve a higher load weight capacity. Just by minimizing the weight, we could drive up our load weight capacity. So after that, we focused on, which were based on our customer research, very important features for our customer base. We focused on our value enhancing trunk features like the grocery hooks, for instance, that were uniquely designed for the pickup truck frunk. You can find, you'll see 5 all around the sidewalls here. And next we integrated 4 D-rings, which are meant for a bit more of heavy use as heavy duty attachment points. And one area that I'm quite proud of is that we managed to offer a customer yet another compartment, which is a subfloor cubby that can be found here. It is washable and it's drainable, and overall just great for an active lifestyle. And then last but not least, I'd like to point out to a huge achievement that was one of our last tasks during our frunk development, and must say it was very, very challenging. We aimed for a very low load height here. It is equivalent to what the customer can find on a Ford Expedition at the rear trunk. And in order for us to achieve that, we had to repackage and look for ways to find volume and reduce weight. And through CAE tools and assessments, we found out that we were able to eliminate 4 out of 5 metal brackets that were sitting just below the frunk floor, and those were leftovers from our ICE package. And by eliminating those 4 brackets, not only did we save weight, we were able to lower the scuff plate that you see right here in Z height, and it also by actually integrating and designing a waterfall grill, it all enabled us to just create this very low entry point here inside the frunk. So all of these added qualities and features required creative packaging, cost and weight optimization, and the appropriate materials and manufacturing choices. So working hand in hand with engineering and manufacturing right from the start was an absolute must for us. Thank you.
So Scott, Elvira, thank you so much. This is such fascinating insight, and I think what I love about this is getting to see both the kind of design features in there, but the customer considerations that kind of like led that really, and then clearly as you both pointed out, those collaborations with manufacturing to make it makeable and also efficiently. So you see how the customer led many of these, and I think that's a really interesting and important point. I think we'll do like 1 or 2 quick questions, because then we're going to come back for more Q&A and we want to come to the others. But maybe one kind of quick point to start on. I mean, when we go back to the design brief and objectives here, obviously, as I mentioned, a lot of ambitions around customer needs and functionality, as well as the things that you expect in a truck, like towing capacity, storage, etc. I mean, how much of a role was lightweighting and reduction, playing within those objectives right at the very beginning? Maybe I can just start with Scott on the Maverick, and then Elvira, you can comment on the Lightning.
Yeah, so great question, Christopher. For Maverick, the goal was 40 mile per gallon plus, right, at $20,000 price point. So, the hybrid wasn't going to do that all by itself, right? You can't just put motors and batteries in and get that efficiency. So mass reduction was really critical. And we're coming from the Ford's, advanced C2 platform. It's very flexible and it had a lot of opportunity for us to move things around differently. And even something as simple as moving the fuel tank rearward behind the rear seat, for example, architecturally, saved mass, gave us more structural boxing in the frame area, and then also allowed massive storage buckets under the rear seat, right? So how we crafted the instrument panel, how we crafted the door trims, all the different pieces in the interior, we're able to take a lot of mass out that wasn't actually adding value to the customer, right? So we focused on using, I call it free geometry. Nothing's ever truly free, but a lot of free geometry created structure and storage and design together because we had to make this massive efficiency jump on the platform. And that all drove our thought process of being super reductive and super efficient through the design process right up front.
Yeah, lightweighting played a huge role for us on the Lightning program. It enabled us to repackage, and with the repackaging of our legacy platform that was handed down to us from our ICE F-150, we had to get creative. We had a limited budget, and we had to get creative in a way where, in order to find more cargo space and enhance our load capacity, weight needed to come out. And with that said, instead of using expensive high-tech materials which were not at hand for us, we went about it in a way where, as I described earlier, in order to achieve the lower load height, for instance, we used the B side of the scuff plate, and we ran CAE analysis and really made sure that our minimum requirements were all taken care of, but any extra weight, any extra polypro that was there on the B side, we literally just went ahead and we carved it out, and that was the method. It was clever. It was just pretty traditional in that sense, but it just required a lot of thinking, and we had to look at every little single part, right? So and the sum of all these little areas where we carved out weight, made a big difference.
Great. Well, we're running a little short on time. We want to go, but I want to ask one quick question, because when we think about pickup trucks, and especially F-150 and any really Ford truck, I mean, robustness, and power, and weight, stance, all these things that are kind of critical design and feature elements of it. Now we talk about this in the electrified age and all of these issues and compressed development times. How much were these constraints, challenges for you as designers, and to what extent though were they actually really opportunities because as you both showed, we've seen so many kind of innovations come out of it. Maybe we'll start with you there, Scott.
Yeah, that's the important point, Chris, is I think, creativity in the absence of restraint or constraints is really, open, but never gets to an endpoint, right? It can be sort of inefficient. When you're forced with, a really low price point, a really fast timing, the whole program for Maverick was the fastest done at Ford ever. Now it becomes a new template for us. In 6 months, we did pencil sketches to final surface release, right? We only spent 3 months surfacing with our engineering teams in our small K loops to get it all done. So that intense constraint set actually unlocked a lot of creative solution sets that we may not have normally expressed, right? So having those extreme targets actually gave us license to try new things. And it was really exciting because, creativity is usually born out of a necessity of some kind, right? And when you don't have those constraints, you can tend to draw lazy circles in the sky, trying 75 different things that may or may not work, where in a fast-paced program, your intuition takes over a bit. Your first guess is your best guess, and you have the courage to go with your gut and you just do it. And it was really fantastic because with a co-located team from Maverick, we were able to sort of find our partnerships in manufacturing, vehicle engineering, marketing, and get just instantaneous decision-making happening, which is really great. Absolutely.
Great. Elvira, would you add anything to that?
Yeah, I agree with Scott wholeheartedly. I think that limitations actually lead to just more focus, and then once we actually find, I like to call them anchor points, something that we can all wrap our heads around, there are still multiple ways and angles where we can actually look at a part and come up with multiple creative solutions from that point on. So I don't see it as a limitation. I think it forces us really to find new solutions.
Fantastic. Well, Scott, Elvira, we're going to bring you back when we've moved through the value chain a bit more now and other parts of them, talking about lightweighting. Thank you so much for this great insight and for sharing that with our audience. We'll see you back again real soon.
Thank you.
Thanks.
And for our audience, if you want to read a bit more about the F-150 from a design point of view, check out our coverage and car design news. We'll have a link come through to you there as well as the Maverick as well. So more to learn, from that design point of view. But with that, I'd like to bring Nick back, and as mentioned, we're going to move a bit more through the value chain. So Nick, I want to bring you on to introduce our next guest.
Thanks, Chris. As you said, fascinating insight there from the two guys at Ford. So if you have any questions for them, obviously put them in the chat box, bottom right-hand corner for later on. I'd like to welcome Robert Strom, Automotive Design Specialist for SSAB now. We're going to have a chat with Robert. Steel is obviously the focus here with SSAB, and obviously the company has been working around with some electric vehicle concepts, and obviously these now being put into actual design and manufacturing applications now. So I'm going to hand over to Robert, and he can talk to us a bit about the Dopol EV concept and some specific parts of it. And then a little later, I'll chat with Robert about some of the key points there. So I'll hand over to you now, Robert. Thank you.
Thank you very much. Yes, hello, I'm Robert from Sweden. I work for SSAB. We are a manufacturer of steel, and we are focusing on high-strength steels. And I want to give you an example about lightweighting, how it looks from our perspective. Because often, or it happens when you let people writing a list of lightweight materials, they forget about steel, and that is justified because steel, if it's soft or is it very strong, it has the same density. So the material itself is not lightweight, but the thing is, when you are using very strong steel and you are using less of it, thinner and so on, you are getting a lighter application. So therefore it should be considered as lightweight material, advanced high-strength steels. I want to give you an example here. We have developed an electrical vehicle concept. An aim with that was never to show finalized thicknesses, etc. steel grades. We wanted to show the potential of the highest strength, of the steels for this type of application, and how it's possible to utilize the steel the most. So we have developed the battery pack and as well as the surroundings, so it's crash safe. Some of the parts we have developed, which belongs to the body, for instance, is this red part. It's the beam where you absorb the energy from the heavier battery, and then also the green cross members, which has to restrain a very high load in compression. And if you're loading a piece of steel in compression, that is very challenging. Maybe the most challenging way of utilizing thin high-strength steels. It's easier to bend and absorb energy and having loads in tension and so on, but compression is very hard. So if you're loading a part in compression like that in the simulation, what you get is a curve, a graph. You can plot it like force displacement, and you are getting a very high peak load, and when you're reaching the peak load, it's getting down very fast, and that is because the beam is collapsing. So you have a peak load, and it's easy to see that the higher the peak load is, the better and more efficient you're utilizing the steel. So if I'm doing a comparison, because the thing is, if I'm saying I want to compress this piece of steel, you can ask yourself, which design should I use and how do I utilize the steel the most? The most biggest part of the load is going through the corners and less through the flat area. You can ask yourself, how big should my corners be? So if I'm adding some profiles here, you can also see I'm adding graphs. I'm plotting it, and when I'm doing a slightly bigger radius, the profile itself is getting a little bit smaller, because if you're getting a bigger radius, the steel is doing a little bit shortcut. So in order to compensate for that and doing a fair comparison, I'm adding a little bit thickness. Only then it's a fair comparison and all profiles are the same. So you can see if I'm adding profiles here, you can see until the side is completely round, that is clearly better than if the sides are flat. But still we need a certain dimension of a beam, and we will have flat segments. And how to deal with those? And there are different ways, and one way is to introduce a groove like this. What you're basically doing is that you are dividing the big wide part into 3 less wide parts, and at the same time you are introducing even more radiuses through where even more forces can travel. So if I'm adding this graph, you can see that it's significantly higher than the rest. But also if you're introducing grooves, etc., and doing the profile more complicated, it has to travel longer. So you can see in this case, I have reduced the thickness in comparison to the base model, but still it's so much better. So then we have learned that the rounder edges are better and a groove works much better than if we're adding those 2 facts. Then we're getting this profile. And then we have a clearly higher force level for this beam. So in comparison to base model, we have increased performance by 112%, more than doubled, only by utilizing the steel the most. So that is basically what we are trying to do with our customers, and it's that this is lightweighting from our perspective. You can choose if you want to use this as extra performance, or if you want to turn it around and design a lighter part. Yeah, that's
Thanks, Robert. That's a really interesting insight. So that brings me to a question here. Obviously, you're working. You can simulate quite a lot there. You're working through various profiles to what arguably looks like quite a simple part of the vehicle structure, but going through great lengths to develop something that has the correct properties, and specifically around this kind of EV application. So in terms of the battery enclosures, which we've read a lot about, we know that they are something of a challenge and ongoing depending on the packaging. Do you see battery enclosures or battery structures evolving? I mean, are they going to become more complex, or are they going to get simpler? What's your view on that?
At the moment, they are really complex, and I think it's depending on what's inside. But in long term, I'm quite sure that it will be more and more simple, and the driving force for that will be cost. Because I see at the moment we are putting cells to modules, modules to packs in cars. But I think those in-between steps will be removed, and we put the cells inside the car. And I mean, the driving force for that is lightweight and cost. So I think it's simplicity.
And that leads me on to another question I was going to ask, because obviously the battery technology, although that's not an area that you guys have to deal with per se straight away, the battery technology we know is developing, the way the cells are organised, the kind of chemistries that they're using. So have you, I don't know if you can reveal this or not, but have you done sort of future sort of concepts and development where the requirements of the enclosure change because of the battery pack system changing? I suppose an example I'm going towards here is the move away from the kind of prismatic or pouch cells that we're seeing at the moment to the solid state ones, which can be packed much more densely, and they'll change their kind of properties. Are you having to, work around something like that at the moment?
No, we are only designing around a black box, so to speak, and I think with less sensitive batteries as solid state, etc. I think that will come to the market very slowly, with beginning on premium manufacturers and so on. So we get used to this quite slowly, I think. Until then, it's for us, it's business as usual.
So you're maintaining focus on what is relatively current at the moment and the mass market, which is obviously where the OEMs are putting all their investment in. Yeah.
Yes.
It's interesting. It'll be interesting to see how vehicle architectures change going forward as well, because we keep seeing a lot about this. It won't look like an internal combustion engine anymore. It'll look like something different. The packaging will be different. So it'll be interesting to see where that leads. Right at the beginning, you obviously referencing steel as a lightweight material there. The development of steel grades has been advancing even before electric vehicles came onto the market. It's been developing, at a pace, and its application as a lightweight material has been used fairly extensively. In terms of the steel, and looking a bit about, I mentioned there a bit about design, vehicle designs in general. Where do you think it's heading, or where do you think it's heading for steel? I mean, are you going to make stronger steels, or steels that have a greater variation in performance?
I think we as a manufacturer, we have made the decision we will go for advanced high strength steels, and we will always try to push this limit. And that is because we want to be able to compete with aluminium, for instance, could be for bumper beams, etc. But of course, you're totally right that we need to look in all properties, and especially formability. So we need very, very strong steel, but it should also be formable. And when we look at steel and cars in the future in general, I'm very confident that steel has a very good position, and will remain as a good material for cars. And that is because we have the formability, we have the strength, and also we have the recyclability, and the sustainability of the steel, and especially cold forming steels. So I'm quite confident that steel has its position in the automotive industry also in the future.
Right, I won't ask any more questions. There's lots of questions to ask, and we'll pick up with you again, Robert, later on in the Q&A panel at the end. So thanks very much for your presentation. I'm going to hand back now to Chris, who will be introducing our next guest. But as we said before, please send in your questions, bottom right-hand corner, and I'll hand over to Chris now. Thanks very much.
Thanks, Nick. And before I just do introduce, just a reminder, if you want to hear a bit more from SSAB, Nick just did a podcast with Robert and a few others as well. So there's a link coming your way to listen to that podcast on more fossil fuel-free steel or carbon reducing emissions there. But as Nick mentioned, let's bring on our next guest, and it's my pleasure to welcome Paul Bellinger, who has more than about 30 years experience in manufacturing and engineering, has worked for the likes of GM and Chrysler, and is now leading the North America R&D Center for Gestamp, and of course is very well placed to talk to us about body structures and body in white and innovations happening there around lightweighting. So Paul, it's great to have you with us.
Thank you, Christopher. Nice to talk to you.
Yeah, indeed. So I'm going to pass over to you now for a few slides, and then we'll come back around and have a few questions after before we go to the panel.
Very good. Hopefully you can see the screen okay.
Looks perfect.
Okay, very good. Well, I'm going to talk a little bit about some innovations, solutions that Gestamp has, not necessarily on the battery structure itself, but how to simplify that battery structure. I think we heard Robert talk about, that looks like could be the future, instead of these very large, extensive from a manufacturing standpoint, battery storage systems that are very expensive, how they need to reduce the cost and make them simpler. And one way of doing that is driving some of those structural requirements back into the body, and we've got some ideas for that. But just a little bit of word for those that don't know, Gestamp, we're a multinational company specializing in the design and development and manufacture of highly engineered metal components, covering the areas of body in white, chassis, and mechanisms, with really a key of designing products that have an innovative aspect to them that enables them to be lighter and safer from a vehicle standpoint, which of course includes the electrification portion. Present in over 24 countries, more than 100 manufacturing sites, 13 R&D centers, with a workforce of more than 40,000 employees. And really one of the key things to driving these innovations into serial production is this co-development approach. We have to start a lot earlier to get some of these really novel and innovative designs into the body structure design path and into production. So the first innovation I want to talk about is actually a combined innovation of material and manufacturing technology. So it's looking at that next generation of hot stamp steels that are approaching 2 gigapascals, and both SSAB and ArcelorMittal are playing in this range. They've developed materials in these higher strength regions. Again, hot stamping them allows us to have that formability that Robert talked about to design complex shapes. So here we have this ability to have very, very high strength, complex shapes. But we've added this other element in using a new manufacturing process to provide some soft zones in very specific areas of these parts. You want the strength, both yield strength and tensile strength, to avoid intrusion for side impacts, for roof crush. But sometimes you need just a little bit more ductility, because again, as you go up higher in strength, It's the natural tendency of steel is you reduce a little bit on the ductility side. So we've developed this approach where we use very relatively inexpensive diode lasers to selectively soften the key areas of body components where you need to have a little bit more energy absorption capability. So some examples here are the B-pillars in that lower flange area where it takes on just a little bit more load in a side impact, just to soften them and give them a little bit of enhanced ductility. Cross members is another good example where, again, just at the very tips where they meet the sills, they need to have just a little bit more ductility. And so this approach is one, again, that enables you to have a very, very ultra high strength steel member, but in very specific areas where you need a little bit more ductility, you can get that too. And here's a video of our first validation cell that we fully developed. This happens to show a rear rail design. This was softening in very specific areas to control the kinematics in a crash so that that rail would crumple in a very predictive and repeatable manner. You can just see the laser diode just for a few seconds softening that area, transforming it from the ultra high strength martensitic structure that you get after hot stamping to a more of a ferritic, softer structure that has more ductility. One of the key things is we can change this and optimize it on the fly. So it helps reduce some tooling costs as you go through the prototype phase, finding out that the soft zone has to be a little bit changed in either geometry or size. I'm able to do that with this process very easily. The next solution set that I want to talk about is overlap patch door rings. So door rings have been in production now for a few years. This is taking that concept but simplifying it, reducing some costs. So instead of a fairly expensive joining method of laser welding, which for hot stamping and aluminum silicon steels requires first an ablation process, this is a very simple overlap design using conventional resistance spot welding. And I'm going to steal one of the things that Scott talked about is free geometry. If we're able to design the overlaps in very key and strategic areas, we're able to eliminate some of the additional reinforcements that might be welded on in assembly afterwards. So we're looking at this both for, we call it single and double door rings, meaning just the front door or both the front and the rear door, and both inner and outer to really have a very strong safety cage for that side impact or roof strength. And a little video to kind of show one of our first prototype parts. And you can see as the red hot blanket's placed in there, you can see where the overlaps are, where the patches are. Those are a little bit different color. So again, it forms this one all into one stroke. Again, if you're able to strategically design these overlaps, you've already got the reinforcements in place where you need them without having to add additional reinforcements. So it's really a very good value proposition that we're trying to come up with. Then the last idea is one that's definitely born from electric vehicles. Now that we no longer have that big tunnel, we can do a one-piece hot stamp floor. And this concept has, again, it's an ultra high strength steel base part with where you typically would have your cross members, you can put a little bit more ductile material as a patch so that, again, it's stamped in one operation, and then you're complete with your integrated floor cross members. Again, it's a very good opportunity to provide a value proposition and a lower cost solution. And again, this is one that's really geared towards electric vehicles that no longer have that tunnel where the drivetrain used to reside. And here's the video of, again, our first prototype application. Again, as you can see the blank, you can see the long longitudinal patches that are in there that will, once it's formed, become the seat cross members. There's the part. So it just goes to laser trimming and then it's complete. So those are some ideas that Gestamp has to improve the structure of the body, therefore allowing a more simple solution for the battery structure for electric vehicles. And with that, be happy to answer questions.
That's great. Paul, thank you so much for those insights and some really fascinating innovations there and opportunities that we're seeing, and sort of connecting well across the things we've heard from Ford and from SAB as well. We're running a little late on time, but let's go to a question or two, and of course we'll pick up more when we get into the panel round. But you know, if body strength and lightness are a key requirement in EVs, are you seeing sort of new and different demands on the chassis structure and components?
Yeah, I think, you know, from the chassis perspective, you know, looking at that front engine area, you know, where you want to have a frunk, where you used to have a big engine control or an engine cradle that used to do a good job of helping transfer loads from one rail to the other, especially for the IHS shallow offset barrier, which is one of the tougher crash events that we have to design for. We no longer have that. So the chassis components that are going to be there really need to take on that responsibility of helping the body be able to transfer loads for getting use of all of the load paths that want to be designed. So for sure, we see some changes coming into how both the body and the chassis have to integrate.
And are you seeing shifts in properties and requirements when it comes to forming and joining when you coordinate with manufacturing engineers and the Gestamp plants or customers, kind of related to those EV structures or other lightweight materials?
Yeah, I think on the joining aspect, again, you know, we're definitely in a multi-material situation where we do have mixed materials, steels and aluminums, which presents some joining challenges. A lot of mechanical joining, a lot of adhesive bonding comes with this. But also when it comes to steel, again, as we're pushing the needle on or the strength level up and up and up, you know, joining can be more of a challenge. Those spot welds can sometimes be a little bit more brittle. So again, how do we, you know, handle that in the spot welding? You could use adhesive bonding. Maybe we use selective softening, again, laser softening to help give a little bit more spot weld ductility. There's different ways that we can do that, but for sure, there are more challenges than what we had in the past.
And then maybe just the last question before we move through and go back into the panel. You mentioned that the 200 MPa and soft stones are processed in the hot stamping process. I mean, how important is that? How much is this about assuring the efficiency of the process, or really more with the strength?
Yeah, so again, one thing that's really important is we have to be able to provide a good value proposition to the OEMs, right? That's one of the key things. And so these materials have to run in our existing processes for us to be able to provide that efficient solution. So that's got to be one of the key critical elements of it. And so far to date, you know, that's been true. We've been able to find ways of producing these new materials in our existing assets, right? Which is, again, that's key to providing a good value proposition.
Absolutely. Well, Paul, thank you so much for these insights. There's more that we're going to bring with you when we bring the panel back together. We're going to move on to our next speaker. So thanks again, and we'll see you in a little while.
Okay, thank you.
And for those of you who want to learn a bit more about other aspects of Gestamp and indeed how electrification is impacting on some of its products and manufacturing, I encourage you to go back and check out the recent AMS Livestream Hour, which looked specifically at the impact of EV production on tier suppliers. And one of Paul's colleagues was indeed on that. So check that out, link coming through in the panel, in the chat. I'm going to hand back over to Nick to introduce our next speaker.
Thanks, Chris. Yep, our next speaker is Jerome Favreau, who's head of automotive at Steel Solutions at ArcelorMittal's Global R&D Centre. So I mentioned before ArcelorMittal's S in Motion Steel Solutions project, which is ongoing and development. And I think Jerome's going to highlight a few key areas of the latest innovations in this now. So with that, Jerome, I'll just hand over to you and I'll catch up with you in a minute. Thanks very much.
Great, thank you, Nick, for the introduction. So I propose to move to next slide. Okay, thank you. So as a talking point today, I have foreseen three main topics. So the first one is to recall the challenge of the electrification of a body in white. And then as a second point, and in fact as a following point, what are the design material optimization we can propose for one of the most important challenge, which are the design of the rocker reinforcement. And then as a closing point, I propose to discuss about a new material innovation we propose to ease the manufacturing and make it more robust for our customers. So on the next slide, I will explain you first or recall you the IC in Motion project. So in fact, the IC in Motion projects are generic projects which are designed by ArcelorMittal, and the idea of this project, in fact, to highlight the benefit of our steel grades for the customer or the end users. So basically, of course, the electrification today is indeed a great trend we have to follow, and that's why still several years ArcelorMittal already invested in steel solution for electrification to help to manage the challenges of this new powertrains and the technologies. And we started with PHEV models and also now with battery electric models. So we have models which could be discussed with customers, and we continue also to further develop solutions like battery packs. We have also rear chassis for battery electric vehicles, and we have further projects currently running to again highlight the added value of our brand new material developments with the last update of the technical development level. So as the next slide, please. Yes, thank you. Here I wanted to highlight indeed the challenge of the electrification on a body in white. So first of all, as mentioned in the early beginning of the discussion, basically on the battery electric vehicle, we have to add from 400 to 600 kgs of battery systems, which makes that, of course, we strongly impact the crash management of the car. Today, there is a key point. The car manufacturers are looking for the highest possible range. And in order to do so, the car manufacturers are looking for a solution to increase on the car the space available for cells. So it means that they have very, very large battery pack, which takes the full size, in fact, of the underfloor area of the battery pack. So it means that, in fact, we have to rethink completely the rocker area. Why? Because we have to make it as small as possible in order to maximize the size for the cells, and also to make it even more performant compared to internal combustion engines car, because we have not only passenger to protect, but also the cells for the entry intrusion. And if you look at the comparison between internal combustion engine and battery electric vehicles, you will see that the penetration in case of the pole crash test, for example, is reduced. So it means that we have a big challenge, which is the optimization design of a rocker part. Here we have proposed at ArcelorMittal an initial design based on both press hardening steel solutions and roll forming steel solutions. So on press hardening, we have proposed a clever design with our Ductibor product. Ductibor, it's a product offering high ductility for energy absorption in case of crash, and Usibor, which is a product which offer high anti-intrusion performance. So basically to prevent a further intrusion into the car. And we have also in this composition some more roll-formed parts, which are a perfect match between the cost and the mechanical properties of the part. So on the next slide, you will see that in fact, we challenge that design. Our first design, which is the one on the complete left-hand side, 162 millimeters times 150 millimeters, which was quite representative of the benchmark, was in fact our initial design. On the complete right-hand side, you can see that in order to manage a crash, we have different ways, in fact. We have the upper load path. So in fact here, once we have a crash, the rocker area collapse, and then the load path goes through the cross member. You have also the lower load path. So here, once the rocker is collapsed, you go through the shield of the battery pack, and then you have the intermediate load path. Once the rocker are collapsed, the load paths go through the reinforcement or the cross members of the battery packs. Here, based on the benchmark, we wanted to continue the optimization based on the upper load path and also on the intermediate load paths, because they are the most representative of the benchmark today. So we started a deep engineering optimization and a fine-tuning of the material needed and the related process. And we went to the conclusion that we could continue to optimize, in fact, the size of the rocker area. So it means that we could decrease the size of this rocker, giving more space for the cells into the battery pack. And thanks to this optimization, we could not only reduce the weight by more than 30% of at the function level of the rocker, but we could also, by the way, increase the range, because we have provided new available space for cells. On the next slide, you will see that then we did also a comparison of our best-in-class solution with what we see today in the benchmark. So on the total right-hand side in blue, you have our design, the S in motion, which fits to a 2.4 tons metric tons car. And if we compare to current benchmark, we see that, in fact, we more or less can close the gap with the aluminum solution in terms of weight. You can see here, it's a benchmark which have been done since thanks to the A2Mac1 databases. And in fact, we have evaluated the weight of the different component of the same parameter of different cars currently existing on the road. So this is why here we think that advanced high strength steels is indeed the best-in-class solution also for the rocker reinforcement, because not only we are very competitive in terms of weight, but we can also have propose a very interesting or a very performant level of low CO2 emissions linked to steel production, and because of advanced high strength steel are today seen as an affordable material. Okay, on the next slide, here I propose to change a bit the topic and move in fact more to the manufacturing. So you can see on the top left-hand side a body in white with a door ring. So the ring basically is a pre-assembly laser welded of blanks, which are hot stamped together in this case and then assembled to the body in white. The difficulty is that we have different thicknesses. You can see here we have steel with 1.4 millimeters, and we are also steel with 0.8 millimeters. As a consequence, the heating speed in a furnace is different between both thicknesses, and somehow we have to find a process window. We have to find a compromise to ensure that the steel will have the good mechanical properties and that the coating will also propose the optimal protection to the steel. So that's why we may have some limitation in the robustness of the process window if we increase the thickness different. But at ArcelorMittal, we are proposing now a solution which is a new coating. It's ThermoBoost. Basically, it's a layer we have at the top of the coating, and in fact help to increase the heating speed in the furnace. You can see on the right-hand side top what's the difference between the UZ-bore standard hot stamping steel and the one with the new ThermoBoost coating. So we can strongly reduce, in fact, the heating rate. And as a consequence, you can see it on the right-hand side down. You can see that, in fact, the process window is increased here by 25%. So it means that we have a more robust process. Why? Because the difference in the heating curve between the thinnest blank and the thicker blank with this improved with the thermoboost coating to improve the heating speed allows, in fact, to enlarge the process window. And the second very interesting point for manufacturing is that thanks to chest coating, we can also reduce the heating time and, by the way, increase the productivity. A last very important point is that thanks to this coating in hot stamping, we are able, in fact, also to reduce the hydrogen intake during the hot stamping process, which is also a major advantage to simplify the process. Okay, now as a final conclusion, I will just summarize the main messages I wanted to deliver to you. Is that first of all, an optimized design with best-in-class advanced high-strength steels and press-hardening steels product can close the weight gap with the aluminum-based solution and can also bring very interesting cost and CO2 reduction compared to some possible aluminum solution for this kind of applications. Then on the manufacturing side, with our new coatings, the ThermoBoost, we can increase the scope of laser welded blanks and more generally the multi-part integration applications by making the stamping process even more robust and also cost effective. And it's also our duty to be ready to support our customer to assess also the technical benefits of our solutions. So if you have some interest, of course, it will be more than welcome to work together. Thank you, Nick, for this proposal to be a speaker today, and I'm open to your questions.
Thanks, Jerome. And again, a great insight there into the development process around not just the steels, but also the manufacturing, the processes as well. So thanks to that. We're running a little bit over, but I just got time for one question. I kind of wanted to bring this to you. There's more questions. We've got the panel thing coming up in a minute, but specifically, given those specific needs around electric vehicles, the battery enclosures, the areas you were talking about during your presentation, how challenging is it to create simple body structures? Because that does seem to be highlighting that I know you're aiming to be as efficient and as simple, but it must be quite challenging to meet all those performance requirements.
Yes, you're fully right, Nick. And as my colleagues from SSAB explained a bit earlier today, the assembly chain is quite complex. We have a cell, a module, a battery pack, which is already a structural, which is after that integrated into a body one with also structures. So there are a lot, in fact, of structures. So today, let's say that we can indeed, it's challenging today to have a very efficient body in white because we have redundancy between the structures, but we can expect that in the coming years, we will see more and more synergies between the designs, and we will likely have much more efficient body in whites. Then it's also important to mention that the cell technology is also evolving in today. So we all have in mind the image of battery electric vehicles in flames because we had some short circuits in cells and then it went to fire. And we can expect that with the next generation of cells, this kind of risk could diminish, and by the way, that can lower the need of mechanical protection around the battery pack, which could be a further point to ease the design of the body in white. But today, yes, the challenge is to try to find the synergy between the battery pack, the body in white structure to make it simple.
Thanks, Robert. What we're going to do now is jump into the Q&A session. So if I can invite all of you stay there, Jerome, and if I can invite all our panelists back. And you can, we recorded a webinar with ArcelorMittal on the SN Motion Smart Steel. There's a lot more detail in there than Jerome had time to talk about today, and some really interesting content around structures. So you can pick on the link there and go back and have a listen to the webinar if you'd like. So we're going to start the questions off. Chris and I we've got a lot of questions for you. If we don't get a chance to ask them all, we'll obviously pass them on to you, and any contact details that are requested, we'll forward all those on to you now, because we're getting quite a few of those via the chat box as it stands at the moment. So I'll start the questions for the panel. I mean, this is kind of a broad one, which I think you can all answer, and the guys before probably have an opinion on this. But I'll start off with this. So, with weight being such a big issue for electric vehicles, particularly the pure battery ones, has lightweighting, which I alluded to before, has always been around. It's kind of there. It's always important. Has that moved back to the top of the agenda when you're engineering projects? Guys at SAB and ArcelorMittal and Gestamp, when you're dealing with the OEMs, and I think we'll come round to Ford guys in a minute. But if I can put that question first to you, Paul, has this issue been lifted up the priority list as far as you can see?
Yeah, I think, I kind of mentioned lightweighting has been, really a top agenda thing for a while. You hear a lot about it more with electric vehicles. Range is critical. Weight is related to range. So yeah, it's important, but it's also important to provide a good value proposition, because there's a lot of cost that's going into these new vehicles, with the electrification, the autonomous portion, right, the connectivity portion. So it's got to be a good value proposition for the lightweighting initiatives. I think that's key.
So if I can get Ford to give me a little bit of an insight into that. I mean, obviously you were talking about the design criteria you had for Maverick and obviously for the F-150 as well. You've been in the industry for a while. For you guys, how is lightweighting sort of, where is it on your list of things to do kind of thing? I know you alluded to it a little earlier.
Yeah, it's becoming a top item because, as customers look for BEV, the first adopters and the second adopters are really considering range as a big purchasing element, right? And then not only for built for tough trucks, it's got to be range when driving around town, but also range when towing, range when doing work. Power to job sites. So you see the power to box elements are coming into play. So I think it's becoming a top priority, frankly. Some of my previous jobs at Lotus and things, I've done a lot of work with the ICCT report to take mass out of different vehicles and proposals. And I kind of have that premise in the back of my head all the time as a designer. But now I'm seeing the whole industry sort of put more spotlight on it, frankly, because of these range situations that people, customers want all the same productivity out of their trucks with the huge range benefit, right? So that provides a unique challenge, especially in the truck space, where I can't, every weight I take out of the vehicle is range, but also I've got to manage payload and cargo. So GVW is just as critical as, absolute weight of the vehicle. So I've got to manage all that together. And I think it's definitely, the dollar per kilogram type discussion happens more and more often, I would say now.
And if I can ask just quickly, get the opinion from our two steel experts. So Robert and Jerome, but Robert, starting with you, do you agree with? I mean, from your point of view, your perspective, and your work with your clients, both tier suppliers and OEMs, are you seeing again this sort of prioritization beyond where it used to be, perhaps?
Yeah, I can only say that I see no difference from an ICE vehicle to an EV vehicle when it comes to the driving force to reduce weight. As I said before, that's business as usual. We stronger and stronger and lighter. So that just goes on.
Yeah, indeed, I can confirm, and I think that we have to follow the same path to continue to develop a higher strength steel with higher formability, because now the car will be also much heavier. So it means that again we will have massive structure which we have to continue to enlighten to make them very efficient. And we have also to think about the CO2 emissions, not only now when we drive the car, but also when we produce the car on the LCA perspective, which makes that we have to continue this effort. And on the steel making side, we are happy to be part of of it by proposing even more advanced steel to reduce the amount, in fact, of materials we use on cars. So definitely, it's a trend which has to continue.
Okay, I'm just going to pass over to Chris now because Chris has got another question here.
Yeah, so Nick and I will pass off so that we don't strain the video screens too much here, as I know we're already stretching across the world to bring this panel together, which of course is really exciting. But I wanted to talk a little bit about the EV architectures a little, and how that might also be playing a role, both in kind of lightweighting, but also clearly in some of the other opportunities and challenges that it brings. But maybe at a high level, are EV architectures in and of themselves sort of a good benefit for lightweighting? We know the battery aspect is bearing weight, but do these architectures sort of point us in the right direction already, or do they bring other challenges? And maybe I want to start with you on that one, Jerome, and then hear from the other panels.
Yeah, indeed. So the structures, the skateboard structure, are in fact very innovative. At least from the European perspective, less innovative from the North American side, because bunion frames are kind of typical structures, but for pickup especially. So indeed, the idea is good, because it will likely help to reduce also the development times of car, and also increase the flexibility of the possible platforms to be developed based on this skateboard architecture. Then, if we speak about standard cars and very high mass production, maybe it could be, yes, an idea to reduce the development time, but it will also reduce the possibility, in fact, to have a very optimized design, because in fact you have one structure already in the rolling chassis and one other structure in the body on frame, which means that it's complex to have synergies, and we have also to manage the assembly between both. So likely a good solution for light commercial vehicles, for car production. Yeah, maybe some limitation due to the field of optimization, which is likely reduced to achieve optimal weight and crash performances.
Maybe I'll go to Paul next on that.
Yeah, so I mean, you know, the added mass and how you change the mass, right, from where the engine is in the front to now in the floor, and with a lot more mass sometimes, with depending on how much the battery is going to weigh, right? That structure change is quite a bit different. So the body weight has to be designed differently to handle that, for sure.
And maybe turning to the designers for a moment. So given both from an engineering and design point of view, I suppose, we know it opens up possibilities, and we could talk about the package of the vehicle and how that does. But yeah, I mean, maybe starting with you, Elvira. I mean, how does it influence when you look at the exterior and working with other teams to account for that?
Yeah, packaging has a huge influence on us designers. It's been lately quite an exciting times, just walking through different studios and seeing really fresh new silhouettes that are being enabled. Some are one can see the positive aspects of them already, but like I can already see certain issues with, for instance, we're playing with like much bigger glass areas right now. That will drive weight up. So it enables us, I think, by with a lower center of gravity, with the batteries being like having a horizontal layout, it enables us to design more of horizontally laid out front graphics and rear graphics. It brings modernity, and at the same time, I think from a visual perspective, what I'm observing, sports cars, we can actually make the overhangs even shorter, right? So it's always been a wish for designers to do that. And then when we go to crossovers and SUVs, we can dial in certain areas with the front, for instance, and bring out the user experience and dial it up. I just think with the play right now that I'm seeing on crossover silhouettes where we're pushing out the windshield and adding more glass to it, that there's going to be a challenge to actually find a balance between weight and modernity.
That's really interesting insight there, and maybe Scott, I think perhaps from the interior point of view as well, how is it influencing you?
Well, I think the big thing is it does pose challenges too, right? We do still have motors and reformers and things that go under the hood, right? So frunks do have a certain Z height. Then there's cowls going forward, possibly or rearward, depending on proportion, and that sets up what's the instrument panel and the interior like. You do have flat floors in BEVs, but there are still items that go under the floor and seating packages and heel points. And now the heel points are getting taller and the sills are going down. So the battery pack wafers themselves make sometimes thicker floors, right? So you end up with a different chair height on the inside, for example, or a different headroom number maybe. And then the breakover angle, the exterior, the sills go down a bit on the truck. So we're always trying to figure out, to Alvarez's point, what's that right proportional balance for usability for off-roading and loading and hauling? And then on the interior side, how do we make sure we maintain that great seating chair height position, for example, with a bigger battery pack, for example? So yeah, there's flexibility on center console, for example, that you don't get because there's no tunnel. You don't get that in an ICE engine. You get more flexibility, say, on a BEV, possibly in the center console. And you've got different instrument panel shapes and cowl placement happening as well. So very exciting time to initially. I think we're sort of reinventing what mobility is and what a vehicle means to people now. And it's, that hasn't happened in my entire career, right? It's been a fairly standard formula with designer on that formula. And now we're seeing much more innovation unlocked because of a new powertrain choice, which is really exciting.
Yeah, and as you point out, though, certainly brings some constraints and aspects as well. But as you talked about earlier, that probably makes it a bit more fun in some ways too.
Yeah, it gives you a challenge to solve, right? Which is interesting.
Yeah, absolutely. Robert, if you want, I don't know if you wanted to add further on that point. Otherwise, we'll bring Nick back into for the next topic.
No, I just wanted to. I agree totally with Scott that this makes developing very funny now. It happens things now which haven't happened before. So it's very inspiring.
Absolutely. I'm going to pass back to Nick.
Thanks, Chris. Well, on the topic of challenges and how much fun they are, I wanted just to ask. Do you think that if you look at the current sort of structures we're looking at now for the current crop of vehicles that are on the market, electric vehicles, do you see that from a point of view where you're looking to save weight, most of the weight, the bulk of the large bits have been dealt with? And if you agree with that, and also where now then, if the, I won't say the easy bits, but the large bits have been dealt with, where do you see the bigger opportunities to shave off the kilos or pounds, whichever way you want to work on it? Where you're kind of looking for those like smaller gains. Paul, can I come to you first with this?
Yeah, so I mean, you have to have a holistic approach to it from a weight standpoint. For sure, there's opportunities to take on additional weight. It's going to require more innovations. Innovations from the material suppliers, which of course you've heard about. Innovations from the manufacturing side, which we talked a little bit about, and also integrating those things into design, right? So there are other opportunities to take out weight. I don't know that you can really say it's going to be in this area or that area, because again, you got to think of it more holistically. But what we're trying to do is do it with a good value proposition, right? We can take out weight by going to different materials that are, let's say, more on the expensive side, but that's something that really can't happen, right? There's just, it's not, the reality is that the vehicles can't afford that kind of cost increase. So we got to figure out how to do it and provide a good value proposition.
Yeah. Can I just go back to the guys at Ford? I know you both alluded to the fact that now, I mean, certainly Scott, you were highlighting some of the areas where you were using your structural parts as decorative parts, so you didn't have to add in, you're saving weight there. And again, with the design of the frunk, which I was fascinated by. I've got to say, that's a an F-150 with a trunk in the front is quite an interesting thing, quite mind-blowing, really. But I mean, in sense of building that in now, you mentioned things like this is now the Maverick project, that becoming a template for Ford going forward. Is it only on those vehicles, or will it be in different segments at different price points? Do you see that being applied further down?
I think the speed of our process is being applied everywhere now. We're in the middle of basically reorganizing how we do business in the studio, and we're going faster. So I think it'll happen everywhere. As far as the way we're thinking through the design work, I'm pushing to make that how we operate it. I mean, I'm kind of in an advanced strategy role now, right? I moved on from production to advanced studio, and we're trying to strategize how we operate going forward, right? What is the right interior space to have, and what is the right element, and how do we set programs up to do those things? So I think there's still a lot of big chunks left, though. To your point earlier, you know, one example, we did a big study for at Lotus when I was there, you know, for the ICCT and in setting EPA regulations for 2020. 80% of the mass of the interior comes from the seat frame alone. 80%. Think about that for a minute, right? Seat frames are the biggest part of the weight. And I believe there's a huge opportunity there to work with new materials and technologies to create much lighter seating, for example, is one of the pieces I would like to uncover in the future. As far as, you know, interior trim, it's about being reductive, and, you know, maybe composites offer opportunity for floor pans that, you know, become trim panels instead of just having sheet metal and covering with carpet. Do we do composite body structures where there's aldehyde composites in the flooring and things that sort of create? These are my, you know, personal ideas and things I'm coming up with and trying to think about, but I think there are still big pieces that we can challenge convention on to make more mass savings. And really it's about high level integration, right? You go, why a composite floor? When a straight replacement of steel may not make sense. However, if I can integrate seatbelt latches and trim panels with that composite floor, now I've eliminated a bunch of interior trim, for example. And maybe it's backed by high strength steel, you know, bracketry and things in the corners. And, you know, it's how do you reconstruct the architecture to make it lighter at all? To Paul's point, it's got to be holistic. If I do it component by component, I will never get true mass reduction. Right? We've got to get up the system and vehicle level discussions where we're making trade-offs about what components don't need to be here anymore. Right? That's the big worldview to me on mass reduction. And on the interior side, I certainly think there's a lot of opportunity to do more of things like Maverick, where elements that are generally speaking structural or B-side elements or substrates become part of the exposed element to the customer. And with product design moving the way it is in the future, I think plastics, for example, become more acceptable as a premium option, right, for use case and for design. Something that was sort of not considered previously, right? You would take the plastic and make it look like leather, right? You put an animal grain on it. Well, that's dishonest, right? And I think being more honest about our approach to material utilization will offer us opportunities to make mass reduction from a pure design standpoint.
Well, it's really interesting, this sort of holistic way of building cars going forward. I mean, it's moving away perhaps from that very step-by-step production line kind of mentality of components from wherever, this joining up a lot more. There's a question here. I just wanted to bounce this other question slightly back towards Robert and Jerome and Paul here. One thing I've noticed, or we had noticed, is a lot of the EV concepts are starting to use a lot of roll form parts. And I know we've spoken about hot stamping here. So just getting your opinion on that. When you see, I'm assuming there are application, you know, areas here that come into play. But do you see roll forming taking more of a part in the vehicle structure? Because it does seem to be favoured by a number of the new EV manufacturers. So can I go to Robert on that one, I think, to start with?
Yeah, I think roll forming is a very suitable method for forming advanced high-strength steels. And it has a lot of benefits. You basically can form about the same as an extruded profile of aluminium in very, very strong steel. And it's a cost-efficient method, and it's flexible especially in terms of length and so on. So I see this. It's a little bit like what Scott also said, that you can't just replace part by part or upgrade part by part. You have to think roll forming from the beginning. So therefore, in order to make roll form parts, you need to reduce complexity of those parts. But if you reduce complexity of some parts, you need to add complexity of other parts, which could be hot stamped. So I don't see it's a real competition between hot stamping and roll forming, rather than a complement of each other.
Can I throw that out to anyone else? Jerome or Paul?
Yeah, so I agree on that point. And on our side, we think that indeed for battery pack and for rocker reinforcement, so due to the more, let's say, quite 2D design, rod forming makes a lot of sense. But for the electrification, as we mentioned, we speak also about much heavier cars and much more energy to absorb in case of crash event. And if we speak, for example, from the front rails, here we need indeed very high mechanical properties, but here roll forming is not adapted. We need to have much more complex shapes. And that's why here, for example, most third generation steels or hot stamping are much more placed, thanks to mechanical properties higher than one gigapascal with a very good crash ductility. So basically, all the technologies have their place on the body in white.
Paul, did you want to add something?
Yeah, I think I'm going to pretty much say the same thing that Robert and Jerome just said. In certain situations, design where your limits are, a constant section, straight, or even now they can stretch bend so it can have some shape to it, but it's got a constant shape, or constant cross section. So it's not applicable in all areas of the vehicle. Where you can, it's a very cost-effective solution. But those tend to be limited from a design perspective. If you can start with it and you can really design around it, that's great. That's not always possible, though.
Okay. I'm just going to hand back to Chris now. Give Chris a turn, so he will have another question for you.
Yeah, great. And I'm going to pull a few audience questions here, and there's more than we can get to. So again, we'll connect to everybody afterwards on that. But one question is, what's the problem? Do you see any obvious applications for lightweight advantages offered by 3D printed metal components, for example, in volume production? And maybe Scott, because you're nodding there, I'm going to turn to you there first. And I think there's a few potential ways we can talk about 3D printing as well for that. But let's how do you see that playing a role?
I think that's a really interesting, groundbreaking new space. And I feel like because of relaxed limitations on die draw and tooling considerations, you could start making beautiful 3D printed parts that are fully exposed to the consumer, right? Where today you might have a few parts that are stamped and flanged and they don't look quite pretty enough to sort of showcase. I can imagine a world where internally reinforced 3D printed structures in concert with the right stampings in the right places, right, bolted with beautiful fasteners, may become, a part of the structure that you can literally show off to the customer. And I think that's where there's a huge opportunity. Getting more into that reductive, minimalistic sort of approach to design and engineering. And then obviously with 3D printing, you have opportunities to sort of do head impact give and, buckle points and on purpose that you want the structure to crush in certain directions, and then make rigidity in other directions that are needed for structural requirements, right? So I think that is, as a designer, my mind gets just expansively blown by all the opportunities in that space alone, right? And then using plastics and metal together and, almost like a co-molded 3D printed two-shot, rubber and material and metal, you can just start imagining, IP crosscar beam seat stanchions being RP'd and 3D printed parts that are now beautiful sculptures that can sit on a desktop, right? Just as well as in your vehicle. So that's, to me, there's a massive opportunity there. We haven't even scratched the surface yet, frankly.
Absolutely. And maybe before we hear from engineer, Elvira, did you want to add anything to that, or is it's in line with how you see it as well?
It is in line. I'd like to add one more aspect to it. The 3D printing helped us actually on the front development to accelerate our process. So For instance, the features that I explained earlier on, the grocery hooks, for instance, the cubby lid, where we added on extra features like a ruler and a little carved out section for folks to put their picnic plates on. That was, we experimented already and evaluated everything already throughout our process based off of 3D printing. So it was a great tool to just accelerate the process and just see it in person. Yeah.
Yeah, absolutely. Actually, I had that in mind too. That the development, prototyping, that's obviously already playing a bigger and bigger role. And I'm sure in the Ford Design Studio, there's lots of cool stuff we could look at there. But maybe on the 3D printing of production parts, components, Paul, would you add anything more to that? I mean, clearly there's still constraints right now, but you know, where do you see possibilities? And I should also add in the mix, another audience question came in and asked, how would it kind of shift when we also had autonomous vehicles with potentially like you know, less accidents? Could it give more opportunity to use, you know, mix that with plastic? So kind of in line with what Scott was saying. So but on the kind of 3D, how do you see it, Paul?
Just like Scott said, from a designer perspective, he is excited, right? From an engineer perspective, we would be excited too, right? Because you can do a lot of different things it's very difficult to do with stamping, with dialogues and stuff like that. Again, right now, I think there's a lot of advancements that need to happen to make it cost effective for high volume manufacturing. So it's not quite there yet to go there, but you know, hopefully someday it will. You know, cost of material and the cost of process, right? It has to come down, and the performance of the material has to go up. But you know, when that comes into play, it's going to offer a lot more degrees of freedom from an engineering design perspective too for structure.
Fantastic. So yeah, Nick, maybe I mean, I know we're kind of running right to the end of time, and I would love to keep this panel going and going, but I might pass it back to you to for at least one more question.
Thanks, Chris. Yeah, and probably just to off the back of that question around 3D printing, but a question to the whole panel. But looking going forward, the technology you're working with now, processes you're working with, materials you're working with, where do you see what individually? I mean, Scott mentioned there 3D printing is very exciting. What is the process or the technology or the trend which most kind of interests you or excites you going forward when you're looking at the developments you've got to work on? So if I can go with Paul with that, probably to start with.
Yeah, so I think there's some short-term things that we're doing that we're able to talk about today. Then there's some medium-term and long-term things, and actually 3D printing is in our long-term R&D portfolio of things that we're looking at. So there's a spectrum. I can't really talk about obviously a lot of those future things, so they're still a little bit protected from an IP standpoint. But there's lots of things that we're working on that we have to continue to work on and innovate to be able to drive these good value propositions for lightweighting.
And Jerome, can you add something in?
Yeah, I think that also one trend, which is the multi-part integration, is also, to my opinion, very interesting, because we start to see larger and larger parts with the aim, in fact, with the manufacturing at the car makers. So we have the example, for example, the example of Tesla. We have also our own proposal. Paul's also made a presentation of interesting concept, and I think that this trend today is very exciting, because it brings new values and maybe a disruptive technology for the next body-in-white designs. So definitely multi-part integration concept are very interesting. Regarding 3D printing, I'm absolutely curious about the impact on the body-in-white development. So far, the body-in-white have always been developed for flat products. Now we have completely to rethink and to design in another way by changing the design paradigm. I'm also very curious how the OEMs will deploy, in fact, this new design methodology and freedom of design. Yeah.
Mm-hmm. And Robert,
I think what's I have to add that what inspires me at the moment is that we have just talking about lightweighting, and which means CO2 reduction and longer range, etc. But I think what is new now, very recently actually, that is that now we have to count in the sustainability as a degree of freedom also already from the beginning. So it's not only the user phase anymore. So this will clearly be a new player to count with, the sustainability CO2 things.
Thanks. I think that's going to be all we've got time for this afternoon. Big thank you to the panel for joining us. It's been really great. The experience and your insights has been fantastic. Design, materials, and manufacturing. So really appreciate that.
Yeah, I just want to add, and I said we could go on, and we really look forward to having each of you involved further in other discussions, live streams, both for automotive manufacturing solutions and of course car design news. And it's, for me, it's just so exciting to put. I mean, you know, I've been to design studios where they have the door that says we don't let the engineers in this room because this is just a creative space, and I'm sure Paul has something similar at the R&D centers. But it's just great to get these different parts of the business together, and companies, both with suppliers within the OEMs, and it's a unique opportunity. So we really appreciate that from all of you. And sorry that we took more of your time than we asked for. So thank you for your generosity with that as well. And just to let our audience know, of course, you know, this will be available on demand for those of you who might have missed some of it, or you want to go back to it. So we look forward to sharing more of that with you, and keep up with us at AMS. We've got another webinar next week if you want to hear a bit more about paint shops of the future. So there's a link there coming at you in the chat if you want to register and check out that. A big thanks again to our sponsors for this session, SSAB and ArcelorMittal. I think we got a great sense of really not just the products that are involved here, but the creativity and the innovations and the collaboration, and a really exciting time and that we're working through now and looking ahead to as well. You know, you can catch up with all of our content. This is the link for Automotive Manufacturing Solutions, where you can catch up on previous live streams. Go to the Car Design News site as well for more broadcasts there. And in fact, there's Car Design News. We're running an Asia-focused event next week. If you're interested, come on Car Design News and check out that. You can see some of Scott and Elder's counterparts in Asia as well, getting picks on trends there. That's it for us here. Thanks again to everyone. Have a great rest of the week, and we're really glad to be able to share this insight with you.